Hello, Aviation 435. My name is Killian Hoyt. I'll be doing my presentation on the CRJ 200 oxygen system. I chose this because I'm kind of drawn more towards the emergency side of POHs and operating manuals. I like to understand how systems work, not just when normal operations, but when things go wrong. So it's not necessarily like a reactionary thing. It's more of like oh no, I already know what's going on, I know exactly what I need to do. So that way my decisions can be made in a timely manner. So I just chose to focus on the auction system to kind of feature more of the emergency procedural side of things of the CRJ 200. Um, I chose to start off with my references just to kind of lay the groundwork for what I was looking into. Obviously, I looked at 91 to 11, and then because this is a more like a commuter or on-demand service type aircraft, not necessarily for general aviation, I looked at 135, 157 of the FAR AIM, as well as I looked at volume 1 and 2 of the operating manual for this CRJ 200. It didn't have a whole lot of information on it. We'll kind of touch on that in a minute. While going through my kind of investigation, I wanted to learn a little bit more about the chemical oxygen system. So I referred to Collins Aerospace to kind of understand how that works and to explain why they would choose that over just, oxygen that would be in like a cylinder or a tank. And then I just wanted to refamiliarize myself with the FAA's guidelines and kind of equipment requirements for general aviation as well, even though we aren't going to be talking about general aviation aircrafts. So this comes directly from volume 1 of the operating manual. It explains that the low oxygen system activates as soon as the cabin is 1,410 psi or lower. Upon activation, it then allows the pilots to descend from 41,000 feet down to 10,000 feet, allowing for a 10-minute descent and then followed by another 10 minutes of oxygen provided to the pilots. This explains too that the acceptable manner that when they're doing their pre-flight, that the system needs to have a certain amount of psi for the pilots to be operate the aircraft, but as well as for the jump seat to be occupied. So you can see here that say at negative 20 degrees Celsius, negative 4 degrees Fahrenheit, with 2 crew members in the cockpit, you need 987 psi in the system. And then if you're going to have a person occupying the jump seat, you need 1,357 psi. So that's just important to know that when you're doing the pre-flight, this is the minimum for the aircraft to operate. Otherwise, it's not usable. It goes on to explain that if you note that the system does not meet the requirements for either the jump seat or just for the 2 crew members on board, that is not the aircraft is not suitable for flight, and then you need to make a note for the for maintenance to then repair or alter that system. Oxygen system operations. This comes from volume 2 of the operating manual. The CRJ 200 oxygen system provides emergency O2 for the flight crew, flight attendants, and passengers. The O2 provided to the flight crew by a dedicated high pressure bottle, so that way they don't have to worry on the complexities of that chemical system. Say it fails, it never activates, they immediately have oxygen provided to them by that cylinder. The flight attendants and passengers receive O2 from a chemical generated system. We'll talk a little bit why they use a chemical generated system instead of just using cylinders like they do for the pilots. Each generator is installed over each pair of seats. So if there is 53 passengers, including the 53 passengers, including the flight crew member or the flight attendants, there's going to be 2 up there by the flight attendants, and then 1 for each 2-seat row, going all the way back to the aft end of the aircraft. As well as there's a portable oxygen cylinder to accompany the protective breathing equipment hood. Basically, if there's an emergency that requires the flight crew or flight attendants to be mobile in the aircraft, maybe for firefighting purposes, maybe first aid purposes, maybe just they need the hood because they're having to vacate to the aft end of the aircraft and direct passengers off, they still are able to receive oxygen without being held to like a stationary source. Passenger's O2 system. So we already explained that it comes from a chemical actuated system. The reason for this is oxygen cylinders weigh a lot. Anybody that's had to move cylinders of compressed air or done some scuba diving can kind of attest to that. Each cylinder is going to weigh anywhere from 10 to 15 pounds when they're full. So that adds up to maybe around 700 to close to maybe 1,000 pounds of additional weight. And you may think that's negligible, that a jet could carry that additional weight. But, that's additional weight, meaning maybe the passenger, maybe the payload, or even the fuel capabilities gets decreased would compensate for that additional weight. So if there's a way to reduce any weight in aircraft, obviously you want to take advantage of that. As well as anytime you're moving and storing compressed air, especially compressed oxygen, there's certain requirements that need to be met by the FDA, but also by the government. And because it provides additional hazards. Imagine there's a fire on board this aircraft, and there's 25 bottles of oxygen, compressed oxygen, that now they got to contend with in the case of an aircraft fire. That's a really hazardous event that they'd have to then plan for. So electing to use an oxygen generated system, it's much more sensible for weight reduction, but also for firefighting and emergency procedures and personnel. Cabin crew system. So again, they get that chemical system, but they have this hood that they get to put on in case they need to be mobile around the cockpit, or not the cockpit, but the cabin. Really the purpose of this is so they're not held isolated to the front of the aircraft. They're able to get to the back to assist in any firefighting or first aid applications, as well as say that after a successful landing, maybe there's smoke in the cabin and they still need to be on board to direct passengers off so they can be the last ones to exit. This allows them to not be held to an isolated station. So the flight crew oxygen system. The pilot's oxygen system is designed to provide 110 minutes of continuous oxygen after a 10-minute descent from 41,000 feet down to 10,000 feet. The quick donning mask is designed to deploy. The pilot squeezes the red buttons on both sides. Once released, the harness of the mask restricts to the head and creates an airtight seal, allowing the pilot to only use one hand. This is a brilliant concept. Imagine the pilots are trying to control the aircraft in emergency. Maybe they're still programming, maybe they're running through the emergency procedures and their operating manuals. The fact that they can quickly don their mask just with one hand instead of having to divert their whole attention over to putting on their mask is kind of a smart idea, in my opinion. But also, if anyone's seen the video of this, it's kind of incredible. Just, it inflates, they put it on their head, they release those buttons, and then a whole thing restricts around their head, kind of like a snake. So for emergency purposes, I'm sure this is brilliant. And then the addition of the goggles allows the pilots to protect their eyes from, say, any kind of smoke inhalation while on board. Thank you guys for your time, and looking forward to y'all's presentations.